The following is an image of a nuclear reactor core. And so in this video, I'm going to give a brief overview of how a nuclear power plant works. Like a lot of other methods that we use to generate electricity, it's ultimately going to result in generating heat to boil water, which creates steam, and the rising or moving steam spins turbines, and the turbines take that mechanical energy, which is in the form of the steam moving, and that converts it into electrical energy as the turbines spin. So, well, how does the reactor work? The idea is this. These departments where you see the four columns of uranium-235 is your nuclear fuel. And what we'll do is we fire some neutrons inside these cores and the chain reactions begin. You'll notice the thermometer at the top right got very hot. That's because in this particular scenario we would have melted down our core and we would have had a nuclear disaster. Now obviously that's not something we want to do. So what we do instead is we use control rods. If you remember about nuclear fission happens by neutrons colliding with uranium-235. So our control rods are special types of rods that absorb neutrons. So as I fire neutrons and keep firing them, eventually the reactions just kind of fade away because the control rods stop them. So what I need to do is I need to find a good balance between generating energy but keeping the temperature under control and moving the rods up and down as needed to make sure that I'm getting reactions but not overheating the core. This is the primary reason why nuclear power plants fail, is because there's issues with the control rods. Whether that means that the control rods are not properly moving up and down, or they've just completely malfunctioned altogether, that's typically what happens and what causes the nuclear reactor to melt down. And if we accidentally put the control rods in too much and completely stop the nuclear reaction, we still have the ability to fire more neutrons. So, what exactly is happening inside the power plant? This here is what we were just looking at in the little simulation. We have the fuel rods, and there will be control rods in this chamber as well, in which we allow nuclear reactions to happen. We have water that we keep under pressure that moves through this cycle here. Somewhere along the line there will be a way where I could supply more water in, because eventually some of this water will evaporate out. Now what happens is, since this water is under pressure, I can actually heat it up above the 212 Fahrenheit or 100 Celsius, and it still remain as a liquid because it's under pressure. So I can get the water to be even hotter than our normal boiling point, which is exactly what I want to do. Why use water? Well, because water is great at taking heat away from objects. So the nuclear fuel rods are becoming extremely hot in this process, and as they get extremely hot in this process, that heat is then transferred to the water. And then pump the water away from the fuel rods and into this chamber here. Now, my hot water under pressure is separate from the water in this tank. The water in this tank is typically your normal pressurized water, so it'll boil at 212 Fahrenheit or 100 Celsius. As it boils away, it generates steam. The steam rises and moves through and spins a turbine. Turbine's connected to a generator. Then we create the electrical energy from the generator. You'll notice that nuclear power plants are most characterized by these giant towers that are not quite cone-shaped, but kind of cone-shaped, a wider base and a narrower top. And we see stuff coming out of the tops of them. Those are cooling towers, and what's actually being released is steam. Contrary to popular belief, the pollution created in a nuclear power plant is mostly contained. The downside is that pollution is incredibly dangerous because it's radioactive. The benefit of nuclear power is, on a global warming perspective, it's great. The amount of greenhouse gases that it generates is far, far less than an oil-based or natural gas power plant, and it's far less than a coal-burning power plant. The downside is we generate nuclear waste, and nuclear waste lingers around for decades, if not centuries, and we need to contain it. There have been some different ideas. Some people said, well, let's blast it off into space and just send that rocket into the sun. Who cares at that point? That would be great, except we can't guarantee that every single rocket that we launch from the Earth will make it into outer space. Although, fortunately, they have been few and infrequent, but sometimes we fail to launch a rocket and it does explode in our atmosphere. And we don't want this to explode and dump a bunch of nuclear waste. Some people said, why don't we bury it deep inside of the mountains? Again, a decent idea. However, we need to get it to the mountains. And there's fear of what happens if one of those trucks is on its way from, say, the east coast of the United States and needs to make it to the Rockies, and there's an accident and the nuclear waste spills and enters into water systems. So that is the number one downside of a nuclear power plant. And then there's also security issues, which actually can up the cost of operating a nuclear power plant, nuclear reactor, because the radioactive waste is so dangerous. There's fears of terrorism. What happens if, unfortunately, a terrorist organization was able to break into a nuclear power plant and acquire some of that waste and then perhaps dump it into water supplies? So security at a nuclear power plant is typically going to be higher and more intense than security at another power plant, such as a hydroelectric dam or a coal burning facility. But to give you an idea about the safety of nuclear power, there have been 3 incidences that come to mind. The biggest one would be Chernobyl. The second biggest one would have been the Fukushima disaster in, I believe it was 2011 in Japan, as the power plant was hit by a tidal wave. And then 3 Mile Island, which was not actually a disaster. The disaster was averted due to some quick thinking of the engineers in that facility. So we have 3 incidences over a course of many decades. But I should also highlight, in terms of how much faith that our nation puts into nuclear reactors. And the best way to say that is we have 10 aircraft carriers in our naval fleet, and every single aircraft carrier operates on a twin nuclear reactor. And then we have somewhere between 60 and 100 nuclear submarines, and each one of those nuclear submarines is also operating on a nuclear reactor. So we do have a lot of faith in its ability to function as a power source. And you may be wondering, well, why would we use nuclear reactors on aircraft carriers and submarines? And the idea is, with fuel, your traditional gas burning types of engines, you need a lot of fuel to sail for a long period of time. The benefit of using the nuclear reactors is our carriers and submarines can be out to sea for 18 to 24 months without ever having to refuel. And that's as they're constantly moving around the oceans. So the benefit of using the nuclear power for naval operations is you can keep your ships out and moving for longer periods of time.